Hi and welcome to my channel. My name is Tobias and today we're going to look at how to differentiate functions using an overview like this one over here, found in normal math textbooks. So on the left side we've got our functions down here, and on the right side we've got our derivatives or differentiated functions over here. So if we, for example, have a constant function, f of x equals c, then the derivative or first order derivative would be equal to 0. So f prime of x equals 0. So let's have some examples for all of these functions and looking at our overview. So first one down here is a constant function where c is just a number. So f of x equals 5. That's our first one. We're having a look at our overview here, so we can see that's a constant function. And f prime of x, or the first order derivative of this constant function, would be 0. So we just write f prime of x equals 0. So if we've got a number on the right side, then we just write 0 when we find the derivative. Equally down here, f of x equals minus 12. Once again, that's a number, and numbers, or the first order derivative of numbers, is equal to 0. So f prime of x equals 0. And if we've got this special case where f of x equals 0, that's also a constant. So f prime of x would be equal to 0. So that was the first one for the constant functions. Then we've got if f of x equals x. We have a look at our overview. We can see that f of x equals x. Then our first order derivative would be equal to 1. So we just write 1. So our function is called f of x equals x. Then our first order derivative or differentiated function would be f prime of x equals 1. Then we've got the next one in line. That's for using a constant times x. Then we just have to look at our constant, our number in front of x. That's our first order derivative. So f of x equals 5 times x. Then we just have a look at the number in front of x, and that's our first order derivative. So f prime of x equals 5. Same down here. If we've got f of x equals minus 12 times x, then f prime of x equals minus 12. Once again, just looking at the number before our x. We've got the next one. That's x squared. If we've got our function called x squared, we have a look at our overview. So f of x equals x squared. Then our first order derivative would be 2 times x. Sorry. So we just write that down, x squared, and down here f prime of x equals 2 times x. Then we have the next one, f of x equals x to the power of 3. We have a look at our overview down here, and we find the function down here, and the first order derivative equals 3 times x squared. So we just write that. So x to the power of 3, the derivative, is equal to 3 times x squared. Then we've got our next function, so x raised to the power of n, where n is a constant. So we just have a look at our overview. So x raised to the power of n. The first order derivative would be to take this number n, put it down in front of our x, and then subtract 1 from n up here, from our exponent. So x raised to the power of 4, we take down our 4, so we note that the constant up here, n, is equal to 4. We put that in front of our x, and then we subtract 1 from our exponent up here, from our n. So that would be 4 minus 1, and our first order derivative would be 4 times x raised to the power of 3. Let's have another example of that. So if we've got x raised to the power of 10, we note that n is equal to 10 this time. We take this number and put it down in front of our x, and then we raise to the power of 10 minus 1, and that's 9. So our final expression for our first order derivative would be 10 times x raised to the power of 9. And another example of this is x raised to the power of 1.5. That's actually the same as the square root of x. So that would be to take our number up here, n, put it down in front of our x, and raise it to the power of 1.5 minus 1. So our final expression for the first order derivative would be 0.5 times x raised to the power of minus 0.5, because if we subtract 1 from 0.5, we get minus 0.5. So that would be our first order derivative. Then we've got a negative number up here, so x raised to the power of minus 3. We take our number up here, put it down in front of our x when we find our first order derivative, and then we say minus 3 minus 1. We do the same every time. So this time we get the final result for our first order derivative would be minus 3 times x raised to the power of minus 3 minus 1, that's minus 4. So that would be our final expression. Then we've got the next type of function here, so that's a constant raised to the power of x. So we call the constant this time a, and we have a look at our overview. And a raised to the power of x would be the same. When we find the first order derivative, we just copy this expression, a raised to the power of x times the natural logarithm of a, so our constant down here. So we just have a look at that. So f of x equals 2, that's our constant this time, our a, raised to the power of x. And then we just copy that to find our first order derivative, so 2 to the power raised to the power of x times the natural logarithm of 2, because 2 was our constant a. We have another expression of this, so 4.5 raised to the power of x. Then we just, to find our first order derivative, we just copy that, the first expression, and multiply it by the natural logarithm of 4.5, which is our constant a this time. And a third example of this, 1.05 raised to the power of x. We just copy our expression up here and multiply it by ln to our constant here, 1.05. So that's our first order derivative. And another one, f of x equals 0.56 raised to the power of x. We just take and copy our expression up there and multiply it by ln to of 0.56, which once again was our constant a. Then we've got our next type of function, that's e raised to the power of x. Let's have a look at the derivative in here. So if we've got f of x equals e raised to the power of x, then our derivative equals e raised to the power of x. So this one becomes itself when we find the first order derivative. So that's a neat thing to do. If we've got this function, to find the first order derivative, we just get the same function. So e raised to the power of x is equal to e raised to the power of x if we find the first order derivative. And the next one is e raised to the power of a constant times x. So let's have a look at this one. First, looking at our overview down here. So e raised to the power of c times x. Then we just have to note what the number c is and put it down in front of our expression. That's how we find our first order derivative. So e raised to the power of 2 times x equals, we note here that our constant c is 2. Then we just put that down in front of our expression and write it all out. 2 times e raised to the power of 2x. So this is just copy-paste, and we just have to note what kind of number is up here, our constant, and put it down in front. So that's our first order derivative of this function. Let's have another one. So e raised to the power of minus 2 times x. This time we note that our constant c is equal to minus 2. We just put that down in front, and we just copy-paste our function up here. So our first order derivative, or f prime of x, equals minus 2 times e raised to the power of minus 2 times x. And a third example, e raised to the power of 0.05 times x. Then we just note our number once again, 0.05. We put that down in front and copy paste the rest. So that's our first order derivative. And minus 0.02 times x. Once again, we just note the number up here, put it down in front, and copy paste the rest. So that's our first order derivative. Then we've got the natural logarithmic function of x. If we want to find a derivative for that one, just go to our overview and look that our function is over here. And the first order derivative is 1 divided by x. So let's have a look at this. We just write it out. So the natural logarithmic of x, the first order derivative is just writing 1 divided by x. So that's a bit special, but if you encountered this function up here and you have to find the first order derivative, you just write this expression down here. Then we've got our expression from before, 1 divided by x. Of course, we can find a derivative for that one too. So we just go to our overview and see that if we've got a function called 1 divided by x, the first order derivative would be minus 1 divided by x squared. So we just write that out. So 1 divided by x, if that is our function, then the first order derivative would be minus 1 divided by x squared. Then we've got the square root function. So we just have a look at our overview. So the square root of x is over here. And the derivative, first order derivative of that function is 1 divided by 2 times the square root of x. So let's have a look. We just write that out. So if we've got our function called f of x equals the square root of x, we just write f prime of x equals 1 divided by 2 times the square root of x. Then we've got our sine function. So if f of x equals sine of x, then we just have a look at our overview. We can see that sine of x equals cosine of x. That's our first order derivative. So we just write that out. And we can see that sine of x, the first order derivative would be cosine of x. So f prime of x equals cosine of x. And the last one, we just once again go to our overview and see that cosine of x, the first order derivative of that one, is minus sine of x. So let's try that out. So if our function is called f of x equals cosine of x, then f prime of x equals minus sine of x. So that was every function in an overview like this one. So you just look at the left side and find the matching first order derivative over here. Well, thanks for watching. See you next time. Bye bye.